Okay. Okay, so I think we'll get started. Let me just share my screen really quickly. Okay. All right. Alrighty. Hi, everyone. So whether you are watching this on YouTube or Google Drive or however you are watching this, hi, my name is Kristen, and this is our first AP Physics C Mechanics office hours. So I will be introducing the course, the exam, from the point of view of someone who took the exam and took the course and did well. All right, let's get started. So we have a lot to cover. So first off, right off the bat, please check out 5Volt's Twitter, Instagram, and YouTube pages. I love their content. I personally like their Twitter page. Just a lot of funny and informative content. Okay, let's go. All right, so today we're going to be going over 5 different topics for today. So we're going to start easy, and then we're going to kind of ease into it, get into the gritty course content, exam structure, and then finally I'm going to do a practice FRQ for you guys. So you can get kind of like a taste of what the FRQ section of the exam will look like, because they are not easy. I will say that. They are long. All right, so let me introduce myself. I'm Kristen. I am the AP Physics C Mechanics TA for 5Volt this year. I currently attend a STEM engineering high school in New Jersey. I took honors physics my sophomore year, and then I took AP Physics C Mechanics my junior year. And I'm going to be brutally honest here. I have a love-hate relationship with physics. I know AP Physics C Mechanics is not the most popular AP subject there is, but nonetheless, if you have chosen to take this course in this exam, it shows that you are willing to challenge yourselves, and that is something that I respect, and that is something that you should be proud of, because this is not an easy course. So kudos to anyone who has chosen to take this course. And yeah, I know that you guys will do great. If you have any questions, you guys know who to ask. I'm always here in the Slack channel. I also have my Notion page that you guys know, that I always post resources, images. I'm huge on visuals. So yeah, so I completely understand the struggles and difficulties that come with physics tests, specifically AP Physics C Mechanics. With the whole calculus aspect, it's not an easy course. But as long as you study, you put the work in, you will all be fine. All right, so I wanted to lighten up the mood just a little bit with some physics jokes. These are some of my favorites. On the left, we've got who would win, an entire year of physics education or one really boy? For anyone who has gotten to the rotation unit yet, which probably not because it's one of the later units, you will know what I'm talking about. Wheels, they look simple, but they're not. And then the middle one, I like this one a lot. Physics, the science where you use extremely long and complicated formulas to explain why a ball rolls. Love that. And then the image on the right, after the end of this course, I promise you will be seeing balls rolling down an incline just like this. So yeah, some fun things to look forward to. All right, let's get into it. So now we got through the fun part. I'm gonna go through a little about the 7 units. So yeah, so there are 7 units that you will be going through this year. And on the right, you can see like how much of each unit will be on the exam, on the multiple choice section, I should say. So we'll start with unit 1. So you guys, if you are taking this course as like a class, you guys are probably in this unit, the kinematics unit. And I'll go through each unit in just one second, but brief overview. You'll be starting with kinematics, which I would say are the basics. Oh, and one thing that you should know about this course, unlike most other courses, Some courses are like this, but everything that you learn, it's accumulative, meaning you could be, actually, not even you could be, you will see things from unit 1 in unit 5. You will see things from unit 2 and unit 4. Yeah, you'll see things from unit 2 with like Newton's third law. You'll be seeing that in unit 7, things like that. So you need to make sure that, especially in this course, especially in AP Physics, C Mechanics, if you are confused at any point, ask for help, because what you're learning, you will probably see again in a future unit. So it's accumulative. I know they seem like pretty different units, like oscillations, like springs. What does springs have to do with like energy, right? A lot. So you're gonna see they're all slightly different. They're all interconnected somehow, some way, by equation, by a singular force that's in common or something. So they're all linked somehow, some way. Some more than others. But yeah, it's accumulative. Main takeaway: if you need help, ask for it. So you don't get confused later on in a future unit. All right, so let's take a look at the reference sheet. So for every AP Physics C Mechanics test that you take in class, or if you're self-studying, this is what you're gonna see maybe in the books that you're working with, or this is what you're gonna see when you actually take the exam. This is the reference sheet that you will see on the left. So this is the one you'll see for both mechanics and I believe also the E&M test. So when you're taking it, so if you're taking just the AP Physics C Mechanics exam like I am, or like I was, I should say, you do not look at the right-hand side. I know it looks confusing. There's like a bunch of symbols and things. Yeah, you don't need to look at that. Your only concern should be this left-hand side. Right now, you might be looking at this and you might be like, what's I? What's J? What's that? So don't worry. You're going to learn what each of these equations are, and what each of these variables are, when you get into the units. But this is just a great resource. You should be using this when you do your tests and things like that, because you do not need to memorize anything that's on here. So, for example, it's good to memorize the kinematic equations. It'll save you time if you memorize them, but just in case, they're always in here. Momentum, let's see what else we have, torque, kinetic energy. Yeah, so work, yeah, so a lot of these equations, they'll be here. Rotational stuff, yeah, so all of the equations will be here. So for the most part, you don't need to memorize. There are some special cases, which we'll go over in, I think, in unit 2, or unit 1, 2D motion. You'll learn about projectile motion, and there are actually equations that are not on here, but are going to save you so much time if you do know. And check out my Notion page if you want to see those equations. They saved my life for projectile motion. So, okay, let's get into it. All right, let's go through each unit. I'm just going to really briefly go through each one. And then we're going to do our FRQ question, which I'm really excited about. Okay, so unit 1 is all about kinematics. You're going to see a whole lot of motion in 1 dimension, a whole lot of motion in 2 dimensions. So problems that involve, I don't know, like a ball rolling down a hill, or in 2-dimensional, right? A guy throwing a ball into the air. So things like that. You'll be seeing a lot of those kind of words, those kind of scenarios, those kind of word problems. These 4 are going to be your kinematic equations. You're going to be seeing them a whole lot throughout the units, not just in this unit. I recommend memorizing them if you haven't already. They are very helpful. They come up again in rotational motion, just in a different form, but you'll see what I mean later. Motion 2 dimensions, that's where we get into things like projectile motion. Like I said before, there are special equations. This is where trig comes into play, right? You can make your special right triangles. Yeah, so again, unit 1 is kind of laying the foundation, making sure you understand, right, motion, kinematics, right, the study of motion. And then we get into unit 2, all about Newton's laws of motion. So I would say most people, right, probably have heard about Newton's laws, right? The first one, object at rest, remain at rest, and objects in motion remain in motion until acted upon by an unbalanced force, right? I feel like most people know that one. Law number 2 is probably the most important one, like equation-wise, right? F equals ma. You're gonna be hearing that a lot. And then you're gonna take a small break, and then you're gonna learn circular motion, right? Motion in a circle. So you're gonna learn about centripetal acceleration, centripetal force. And then finally, you're gonna go back to Newton's third law, and that is for every action, there's an equal and opposite reaction, right? So equal in magnitude, opposite in direction, which is kind of cool. And that plays a role actually in the last unit, gravitation, which you'll see. So again, all these units, again, they come back again and again and again. So it's important that you know what you're doing in each unit. So yeah, so these are kind of laying the foundation again. And then we get into probably the meat of AP Physics and Mechanics. Now we're getting into more trickier things, I would say. Unit 3, work, energy, and power. I would say in my class, Unit 3 was probably the hardest unit that we all agreed was probably the hardest unit, mainly because energy, because I think, okay, so let me just go back for a second. I would say the first units are fairly simple because, right, motion. We can picture a ball rolling across the floor. We can picture, right, a football, flying, across in the air. We can picture all that stuff. We can picture, right, like someone swinging a ball on a string. We can picture that kind of stuff. But then we got things like energy. We can't really picture kinetic energy or potential energy. We can't really picture things like that. And this unit is very heavy on equations, theorems. You're gonna learn about equation for power, how to calculate that, conservation of energy, how to calculate the work energy theorem, force, potential energy, their relationships. You're gonna see how they're all connected in their own special ways. Like for example here, right, we're at the work kinetic energy theorem. Already we're connecting the concept of net work with kinetic energy. And I don't know about you guys, but I literally took the class and I still can't visualize like what is work. I mean, obviously you guys are going to learn what work is, right? How it's related to force and displacement. But yeah, this is not an easy thing for an everyday person to just visualize, right? So this is where I'd say is probably the harder stuff because it's a lot of not things you can visualize. It's very theoretical. It's very equation heavy. You got some calculus in there. You're gonna see. So yeah, there's calculus. I would say the most calculus from my experience was Unit 1. You're gonna see like going from displacement to velocity to acceleration. There is a way using derivatives and integration to calculate between the three. And then same thing for energy power. There are integrals that you can do. You can use to find certain things from certain concepts. And then Unit 4, I'd say was a little bit on the lighter side, but still pretty dense. Center of mass, again, I can easily picture center of mass. I know sometimes when I'm bored, I'll just like balance like a pencil on my finger and try to like, I don't know if you guys can see me, like balance, oops. Yeah, I don't have good center of mass, but yeah. So trying to find a center of mass on my pencil, right? Sometimes I'll do that when I'm bored, like that I can picture, that I can like visualize. So it gets a little bit easier. Impulse and momentum, collisions, yeah, like cars crashing into each other, things like that. And a little bit of Newton's laws. And again, I'm going to tie something together. Like you're going to learn about how Newton's third law plays a role in collisions, right? Everything is connected. Like I said before, everything's connected, which is cool. So again, if you are confused in one unit, speak up, ask for help, things like that, because you don't want to get lost in a later unit. It's actually Newton's third law plays a huge role in collisions, so you want to make sure that you have an idea of how Newton's third law works. All right, so keep moving. So I want to make sure we have time for our FRQ so we don't go over time. All right, and then we got rotation. So here we've got things like torque, rotational statics, rotational kinematics. And you can take a look if you remember, right, the 4 kinematic equations for translational stuff, right, and you compare to this, right, they look, I know the symbols are different, but they look similar, right? So you can see, right, you don't need to memorize a whole new set of equations, right? If you can find those relationships, make your life easier, you'll see that the translational stuff is almost identical. And actually, it is identical, except for yours translated into rotational language. And yeah, you're gonna learn all about the angular rotational stuff. Basically, I would say Unit 5 is just everything like with momentum, the things we did in Unit 4, things we did in Unit 3, things we did in Unit 2 and Unit 1, now just translated into rotational stuff. It's like the accumulation of everything we've done so far, but now let's look at it the rotational side of it. So like, wheel, that's where wheels come into play. That's where, right, when we twist, like you can see in this image, right, angular momentum and things like that. So anything that's like not in a straight line, basically, is rotational. So that's kind of cool. So like torque, you think of like opening a doorknob, right? Opening a door, right? Things like that. So yeah. And then we get into oscillation. So here's like a slightly different topic, still kind of takes some knowledge from past units. You're gonna learn about simple harmonic motion. Think of pendulums. Think of pendulum. Springs, pendulums. Yeah, so there it is. A little bit again with trig, sine waves and things like that. You're gonna see how they're related to springs and pendulums, because again, they're all related somehow. And then finally, gravitation. And this was, I would say, the most interesting unit in my opinion. It kind of includes most of, especially with the thing about like force, Newton's law. And yeah, here it goes, Newton's law. I think it's a pretty interesting unit because now we get to learn, if you're into like planets and things like space, this is the unit for you. It's really interesting. It's slightly different than the past units, I would say, because it focuses more on like shapes, like orbits. Obviously, there's equations for everything in this course. But yeah, it's a little bit more fun, I would say. Yes, who doesn't love space? And yeah, so gravitation explores all of that, which is cool. All right, so I think it's basically it. Again, this was a very brief overview. I hope in the future I can do more office hours where I can like really go in. I can maybe like go through each unit in depth. I would love to do that. Again, today was like a super brief overview, barely skimming the surface, barely tip of the iceberg. So really brief. This was just like me rambling for the most part. But now let's get into the fun part. Let's get into our first FRQ. So I took this from the 2017 AP Physics C Mechanics FRQ question 1. Heads up, there are 7 parts to this question, right? A lot of people go into thinking, oh yeah, the FRQs are just gonna be like, one question, maybe 2 parts, 3 parts. No, there's 7 parts. And yet these questions are not designed to be like, oh, done in 5 minutes. You have to allocate a good chunk of your time to these FRQs. Okay, so I'm gonna go to the next slide. Okay, so if you guys are watching this on YouTube or like another platform and you're watching this right now, please pause the video. See if you can solve these questions. Here, I'm gonna go through each one. I'll wait like 3 seconds so you guys can pause the video, answer it on your own first. I try to pick this one because, again, I'm hoping that most of you guys are in Unit 1 by the time, so how would they? We're on October 1st, so this is October 1st, by the way. Hopefully you guys should be in Unit 1, maybe Unit 2. I don't know how fast your classes are going, but you guys should be at least in Unit 1 right now, so we should be somewhat familiar with, things like mass, things like acceleration, free body diagrams, which I'll go over in today's FRQ review. So, all right, so if you guys can just pause this video right here. All right, hopefully you paused it. I'm just gonna go to the next slide. So if you want to just like really quickly, if you have no idea, that's okay. You can still pause the video, take a look what these questions are asking. I see a graph question, a table question. Go to the next slide. All right, and then this is the last part, G. Pause it right here, read through it. If you have an answer, go ahead, fill it out. If not, just read through it, see what we're gonna be working with today. All right, and again, let me just go back for 1 second just so I can give credit to what credit is due. And also if you want to extra practice, this is from the AP College Board website. College Board has so many, I think it dates back to 1999. I was checking before. They have all of their FRQs since 1999. The best way to practice, I think. And also you should at least be practicing FRQs. I would dedicate like an entire month. I would say April. That's what I did and I felt more confident. Although last year's AP exam did not look the way it usually does. This year it's going to be the full one. If not the full one, it'll cover the entire content, I believe, but it's all up in the air. We don't know, but let's just prepare for the full exam, multiple choice and FRQ. So yeah. Okay, so let's just jump in. So again, I got this from the AP College Board website. They have all FRQs since 1999 that you can practice with. Okay, so let's jump right in. So I'm just going to pull this up really quickly. So an Atwood's machine. I don't know if you guys learned about those yet in class. I know that in my class we had like a whole experiment with them. I know my teacher had brought in an Atwood machine, which was cool. It was like a handmade or like a personally made one with like string and little blocks. It was cute. So an Atwood machine is fairly simple. It's literally just 2 blocks connected by a light string, meaning massless. We're going to assume that the string has no mass, otherwise this will make our problem very tricky. Frictionless pulley. I know it doesn't seem very realistic, but again, this is all just to make our life easier, right? Negligible mass. We like to hear that, right? Because otherwise, if the pulley had a mass, this would make our problem a whole lot different. But we're going to assume, right? We love light string, frictionless pulley. All right, so really the only things we need to worry about are M1, M2, masses of the 2 blocks. And this is pretty important here. I'm going to pull up my pen now, I think. Let me pull up my pen. All right, so you can see this is a pretty important detail. M2 is always greater than M1, meaning, right? So let's just forget about physics for a second. So the reason why I picked this problem is because this is very easy to visualize. Like I can literally like see this Atwood machine in front of me. I can see these 2 blocks, right? If M2 is heavier, right, which way is the string gonna go? Gonna go that way, right? So let's just draw some arrows to describe the motion. It's gonna go that way, right? It's gonna drop to the ground, right? It's gonna go, and M1's gonna go up, 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 right? Oops. Let me pull that out. Okay. Oops. Sorry. So yeah. Okay, so that is the first part, understanding how this machine is gonna work. Okay, so next, let's see what the first question is. On the dots below, which represent the blocks, we're going to draw and label the forces, not components. That's important. So components are more for like, for example, when I think of, oops. Okay. For example, if you have like an inclined plane, right, and it's all tilted and like your axes are like this, but then you have a force that's like way off, right? You have to have components. In this case, we don't have to worry about components and things on the axes. But it's still good to note that. Okay, so however, this is important to note that relative lengths of the arrows should the relative magnitudes. Okay, so let's do block 2 first, since we kind of understand how block 2 is going to work, right? Block 2 is heavy, right? And we know, right, that it's going to accelerate this way, right? Let's just draw this one. Block 2 is going to accelerate this way because it's going down, 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 down. Whereas block 1, right, it's going to accelerate up, 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 right? It's going to go like this. So we can just quickly label that. Block 1 is acceleration this way. Block 2, acceleration is down. So for block 2, right, 4, right, acceleration to go down, right, we need the force, the down force to be greater, right? That's why it's accelerating, going down, because the force of its weight, right, and we all know that weight is equal to mass times gravity, right? So we can call this m2g. Let's be as specific as possible because we don't want to confuse it with mass 1, right? So make that arrow super long, right? Right, that's what's causing, right? Because it's heavier. The reason why it's accelerating downwards is because the weight of the block is heavier than the string. And that string, the force of the string is called tension, right? So tension, that's something kind of important to note, right? So, right, so whenever you think of string, you should automatically think of tension. That is the force that's associated with string. Whereas for block 1, right, why it's going up, right? Because the tension force is greater, right, somewhat greater than the weight of the mass 1. So we can make this, right, we can make just a little bit long, oops, a little bit longer. That's a tension force, just a little bit greater M1G, actually, I think it's a little bit longer, it's fine. You can kind of say this is M1G, that's tension, the tension force is greater than the weight of M1, meaning it's going to accelerate up. All right, those are your free body diagrams. Free body diagrams are important. Labeling your vectors, right? I mean, you could have also written, instead of M1, you could have just written weight of 1, weight of 2, that's fine. There are multiple ways. For tension, right, you could have done force of, I know some people do force of T, right? T is a little on the bottom, little tiny one. But it all means the same thing, which is good. All right, so let's keep moving. So I'm just gonna erase some of the stuff on the side. Let me just erase some of the underlines so we can take space. All right, let's take a look at B now. All right, so B is asking, using the forces in your diagrams above, write an equation applying Newton's second law to each block and use these equations to derive the magnitude of acceleration. Show that is given by that equation. Okay, so right off the bat, we have to understand what's going on, right? They already gave us the answer. Did you guys notice that? They already gave us the answer. They're asking us, they want us to apply Newton's second law to each block and show that it can give, or it can result in this, A equals that big thing. Okay, so the first thing I would do, take a look at my block. So let's do it for each block. So let's take a look at your net force. Oh, and really quickly, I realized we forgot to do one thing. I always like to do this for my axes. Remember, you always point the positive x direction in the direction of your acceleration. So I drew my little pretend axis. So positive x for mass 1 will be up. So going this way is up, positive. And for block 2, going down is going to be positive. It's important to kind of set your axes correctly. Kind of rule of thumb, I would say. Okay, so let's do the first one. Oops. Okay, so we know up is positive, down is negative for block 1. So let me just label, so the sum of the forces, we might run out of room. I might have to move to the whiteboard. Actually, you know what? I can already see this. I'm gonna run out of room. Let's open a whiteboard. No worries. Yeah, we don't even need to see the answer because we're gonna get the answer. All right. So again, let me just really quickly draw the free body diagram so we don't forget. This is mass 1. This was M1G, M1, oh gosh, G, and then this is F. Oops, a little smaller. And then make this guy big. M2G, there we go. All right, so those are our free body diagrams. Now let's draw some F equals ma equations, right? Newton's second law. So let's do block 1 first. Oh, and then, oh gosh, hold on. Positive x is this way, positive x is that way. All right, now we get started. So it's a little messy. All right, so sum of the forces in the x direction for block 1, we've got T, right? Then M1G is in the opposite direction, that's minus. And that's equal to M1A. Let's do the same for mass 2. In this case, right, positive x is down, right, because acceleration is going down, right? So the reason, again, one more time, the reason why we have set these as our positive x directions is because that's the direction of acceleration. So for the second mass, we can say it's M2G, and the tension is in the opposite direction this time, minus T equals M2A. And then finally, we can combine those equations, right? Put the system into G minus, put all the forces on the left side. So I'm basically combining, right, the two equations. So putting all of the MAs on the other side, right? M1, A, we'll do a little of, remove that A. M1 plus 2, hold that in a second. Oh, and then right after that, this is where the fun part happens, right? Negative T plus T, they cancel out. Awesome. Now we are left with M2G minus M1G equals, here we can just remove that A, take that out for a second, because remember, we're solving for A, right? That's what, they already gave us the answer, and you're gonna see for a second, we're gonna get the same answer. Again, they're not asking for the right answer, they're asking to show us, so this is what you would kind of show. All right, and then here's the final step. We divide both sides by m1 plus m2, and ta-da, oops, 2. And if you want to even go a step further, I'm just gonna here, I'm running out of room here. Let me just erase my free body diagram, so I think we're done with that part. Finally, in this hand corner, upper hand corner, A will be equal to, right? We can remove that G for a second, right? Take a look, we can get M2. Right? Just a little bit of moving around, we can get the answer that they had, right? This is exactly what they had written. It's M1 plus M2, and then all of that times G. And ta-da, we just got exactly what they wrote. That crazy little thing, we just got it too. So yeah, I know it looks complicated. I think that's like the magic of physics, right? Everything looks complicated, but once you start plugging things in, getting your equations, it all makes sense. Quick water break. Okay, let's continue. So let me just go back to, where is it? Here. I think it's here. All right, so we solved that, and ta-da, that's exactly what we got. So we can move on. We just have, I think, 5 more sections. So we're not going to do the graphing. I'll show you how to do it though, but okay. All right, so next, what's it say? All right, so now we have a table. Indicate, right, this is where we have to either put on our thinking caps. Indicate below which quantity should be graphed to yield a straight line whose slope could be used to calculate a numerical value. Oh, that sounds like a lot of words. All right, let's figure out what this actually means. What does this mean? This means, what can we graph to get G? Straight line. Oh, I missed that part. Straight line to get G. Well, that seems like a lot of words, but I see straight line. If anyone remembers this from like algebra class, right? The first thing that comes to mind when I think of a straight line is the y equals mx plus b equation. Right, so what's m? Oops. Oh my gosh. What's m is the main question, right? What's m? Oops. It's a little clearer. Yeah. So we are looking for the slope of the line. So y-intercept is not too important here because right now we are mainly just thinking of like the y and the x. And let me just show you, I'm going to show you why in a second. But this is what should be going on in our minds right now because this is a lot of words. Your brain should automatically think of y equals mx plus b, right? We need to have a unit assigned to the y-axis, a unit assigned to the x-axis. So we can take a look. Hold on. We're going to take a look at the equation from the last slide. Oops. This one right here. Right? This one right here. Doesn't that kind of look like y equals mx, right? And this is why I'm saying the plus b is not too important here because if you look too much at the b, like you're like that doesn't look like that, but this looks exactly like that, right? And right, take a look. Isn't this what we want, right? We want gravity, right? Because the whole point, if we look at the next slide for a second, it's like we're like detectives here. We are trying to, right, whose slope could be used to calculate G. That's what this fancy is saying, right? Slope G. There we go, slope G, mg, right? So that would mean y is a. Oops, let me put my mouse over here so the black thing is not, the black bar is not covering it. All right, here we go. So y is a, and x, guess what? Is that crazy weird looking thing, m2 minus m1 all over m1 plus m2. And there we go, we just got it. So, right, take something from algebra that we know about, y equals mx, try to relate those two, and yeah. All right, so now, all right, so first we have to label, right, I'm not gonna just write, I'm just to save time, I'm just gonna kind of verbally say it, right? Vertical axis, we will label it as a, because that is our y value. Horizontal axis, because that's what we're multiplying by the slope, x, right? So that was the m2 minus m1 over m1 plus m2, right? And then the slope m is g. That's what we're gonna get. Okay, so let me just pull this over here. Yeah, so that's how you would do that. You have some points here, right? You can, so for the M1, M2, obviously you have to plug that into the weird like M1, M2, whatever equation thing. And yeah, you would graph it. And just to save time, hopefully you guys are familiar with graphing. If not, let me know. I can do like another session maybe on graphing, but hopefully you guys should be good with graphing. Should look something like that. Oh, should be straight line actually. Straight line, something like that. I'm not 100% sure, Once you graph it, it should come out like that though. Just to save time, slope, right? Again, don't overthink it. Remember from algebra class, right? Slope is change in y over change in x, right? All you have to do, pick 2 points on that line, this point and this point, right? Subtract the y values, subtract the x values, and you should get, if you do this correctly, a number that's somewhere between 9 and, I'll be generous, 9 and like, I don't know, like 11. Anywhere between those two numbers. Because remember, oops, let me put this over here. Hold on, my computer's being a little slow. Okay, that's fine. So again, gravity, acceleration of gravity, we all should know, right, is 9.81. Write this down right here. That is literally what it is. Or that's the kind of rounded number, but it should be that, right? That's the number we should get. However, you know, because we're not actually, you know, we like at this point we're pretending like we don't know this, right? We're actually solving it for it manually. It should, as long as your number's between here, you should be fine. You did it correctly. If you get like 2 from this, if your slope of your line is 2, then you did something wrong. If you get like 50, you know you did something wrong. But if you get somewhere between 9 and 11, you should be good to go. All right, we're doing good. So again, this was just a graphing one, nothing too bad, but here we go. Here's where the real physics comes in. All right, this is a doozy. This is probably what when I looked through this the first time, I would say that F is probably the hardest question on here because it is so like, requires a lot of thinking, a lot of steps, a lot of things that it requires you to like think about, which is kind of a little bit crazy, but I will go through it. So hopefully you had a chance to look through this. If you got it, you got it, great job. If you're still a bit confused, I will go through it. So as you can see here, the experiment is now repeated with a modification, right? The Atwood machine is now set up so the block of mass M1 is on a smooth, right? Smooth, no friction. That's very important. Oops, oh my gosh. Yeah, no friction, really important. However, mass 2 was kind of hanging over. All right, so right off the bat, the first thing we should do, figure out acceleration. I mean, this one's kind of easy, right? Just picture this, right? You have a block on a table, it's just chilling. Then you have a block, right, hanging over the floor. It's gonna fall because of gravity, right? So the acceleration is gonna go like this. So let's just draw the arrows really quickly so you know, visualize it. That's what it's gonna look like. So now it's asking, this is a really interesting question. So M1 and M2 are exactly the same. They're not changing, right? We know mass can't just magically change, can't just increase or decrease. So it's asking, is the magnitude of a tension, so we're now going to look at the string, tension in the string when the blocks are moving, accelerating, higher, lower, or equal to the magnitude of the tension in the first experiment? So this is a tricky one. So right off the bat, I just want to go back for a second, right? The first experiment, right? If we remember the free body diagrams, both of them, and I remember they're very similar, right? Do you remember it was like, for both of them, it was like something minus something, right? For, I think it was like tension minus M1G for one of them. And like the other one was like M2G minus T, right? Something minus something, right? However, in this case, let's draw the free body diagrams for a second. Let's just keep it up there. Something minus something. I should just save space, I'll erase that. In this one, right, we can look at the block 1. It's accelerating this way, right? It's being pulled by tension, but there's nothing here. There's no force. Isn't that, you know, that's kind of, right? It's got to do something with, you know, here, right? It has to do something with it. But then block 2, it's the same, right? Block 2 is exactly the same, isn't it? Right? It's going to be M2G minus T, right? If you draw the free body diagram, you should get that. So let me just skip that step. So really, mass 1, the net force is equal to just T, right? Isn't that kind of weird? So let me just pull this up. So we're not subtracting anything, right, from T, right? Oops, let me move this over here for a second. Which means, so now this is some deeper level thinking. I'm sure that, and now, okay, one more thing. There are multiple ways to do a problem. This is what my brain kind of thought of first when I saw this problem. There are probably multiple ways to solve this problem. But this is kind of how my brain approached this, right? So because, right, we're not subtracting anything from mass 1, right? It's just T. That means the net force increases, and therefore the acceleration increases. So let me just pull this up for a second. Right, so this is just T. It's not something minus something, it's just T.